Okay, quadrilaterals. Lots going on here, guys, and I'm going to try to make this a quick video, and a lot of it is not necessarily teaching, but just you having a resource so that you can go and write down all these properties later if you like. We're going to talk about in this video different types of parallelograms. So we're going to talk about rectangles, squares, rhombuses, and just a generic parallelogram. So all of this stuff listed on the left are the properties, and so I've marked my picture accordingly. So you'll see all the different congruent stuff, congruent opposite angles, you'll see congruent opposite sides, you'll see that these diagonals bisect each other, which makes these two pieces congruent. So make sure you know at least the markings so that you can read a picture and know what you're looking at. The rectangle is all the properties of the parallelogram apply because it is a type of parallelogram. So basically all the stuff above is still true about a rectangle, except now we have added an interesting dynamic where it says the diagonals themselves are congruent. So if they bisect each other and they're congruent, it means that all of them are equal to each other. And what this does, this is my favorite part of this shape, it makes like two congruent sets of triangles. So like if I know this triangle, I can then fill out everything true about this triangle, and the one on the top is going to be congruent to the one on the bottom. So that's kind of how I have dealt with rectangles. Moving on to the other two types, we're going to skip kites for now, the rhombus and the square. So rhombus and squares are kind of in the same family as well because they have congruent outside pieces, and I have just read through the list that's on the left, and I have marked my pictures accordingly on the right. So make sure, once again, you at least know how to mark your picture and you know what's congruent to what. I think the most special thing about rhombuses in my mind, besides the fact that the sides are all equal, is that on the inside, these diagonals bisect not only each other, but they bisect the angles. So if I know this angle, then this one is going to be congruent. So that's kind of nice. These two are the same, and if you go across the picture, it means that all four of those are going to match. And same thing here. These are all four going to match. So I think that's awesome about a rhombus. And then a square, of course, is going to be the easiest of all because pretty much everything's congruent. I mean, all these angles match. The diagonals bisect at 90 degrees, just like on the rhombus, and then all the sides in the middle are the legs, and they become they're congruent. The outsides are congruent. So just kind of keep that in mind. So on a square, it should be pretty easy to find the missing component. And if you need to pause and draw these, do that. Or mark down the congruencies on all these shapes. But it's really important because when we go to do some practice problems, you're going to have to know what's supposed to be true about the shape so that you can find the missing parts. So that's what I'm going to do next, is make up a few problems. So once you've copied these four down and all of what's going to be congruent about each other, then you should hit pause. Once you've written it all down, then you should hit play, and I'll do a few examples with you. Okay, so here's an example of, you can be given any shape and you're going to be asked to find random stuff, right? So the given is that I'm telling you ABCD is a rhombus. So that's supposed to put you in this frame of mind to start thinking about what's supposed to be congruent to what, and what are all the properties of this shape to help us solve it. The only other given is that the measure of angle ABD is 25. So I'm going to go ahead and write that in. ABD is 25 degrees. Okay, so since it's a rhombus, we know a few things. The first thing that my brain would jump to is the sides, and the fact that on a rhombus all sides are congruent. So this is supposed to equal this and this and this. So these are all equal to each other. So if I want to find x or y, I would go ahead and just set some sides equal to one another. That would probably be my first step. Now, I could set the opposite sides equal to each other, but that might not be smart because one of them's got an x and one of them's got a y. So instead, I think I'm going to set this one equivalent to this one because they both have the same variable. And then I'm going to solve. So let me subtract x from both sides, and let me add the 26 to both sides. And I am getting, am I getting that? Yes. So I am getting that 2x is 20, so x must be 10. Excellent. So now, what do I do now? Okay, so that's x. Now let's find y. So let me set these other two guys equal to each other to find y. Equals 2y plus 4. Okay, so same thing. I'm just going to move variables around and solve like an algebra problem. So if I subtract the 2y from both sides and then I subtract the 4 from both sides, I get that y is 0. So x is 10 and y is 0. Now, sometimes it's helpful to go and plug these back in to find, you know, what the side is going to be. And if I do that, if I plug my 0 back in up here, it looks like 2 times 0 plus 4 is just a side length of 4, which means that all of these are going to be a side length of 4. Now, I don't know if I need that information or not, but sometimes it's worth finding in case we need that later. All right, now I'm going to go to the inside because the only thing I haven't found is z. And z is on the inside right here. It's on this inside. I'm assuming it's from here to here. And if I'm supposed to find that, it's a side length. And it's not 4, but we do know that on a rhombus, these intersect at a 90-degree angle. We also know that these are all congruent to one another. So if that's going to happen, wait a minute, I'm a liar. That's not going to happen. That's the square. Haha. See why you got to know your, oh crap. See why you got to know your stuff here? Let me get my eraser that's not going to erase everything in the world. Okay, so I just want to take away, hold on a second, guys. Sorry. Okay, let me draw that back in. Yeah, that was not good. Okay, they bisect each other. They're not necessarily congruent, which means I'll do 1, 2, 3, 1, 2, 3. So you can always go back and look at your picture, right, to make sure where you can be like, oh crap, what's true about a rhombus? Okay, there it is. They're not equivalent to each other, but each little piece, like, they bisect each other. So that's congruent to that, and that's congruent to that. Now, I think what I'm going to do is use the angle to help me. So if I know this is 25, the other thing about a rhombus is that it actually cuts these into equal parts, like it bisects the angle. So 25 and 25 would go there, and opposite angles are congruent. So 25 and 25 would go there. And this is me just looking above and knowing what's supposed to be true about a parallelogram or a rhombus. Now, if I know, this will be fun. If I know that this is 4 and this is 25 and this is 90, then hidden in this picture is a little right triangle right here. Okay, and on this right triangle, if I examine that closer, I'm going to actually redraw it right down here, guys. What I'm looking at is a 90-degree angle here. Z would be here, 4 would be here, and 25 would be here. Does this look familiar? It does to me. I'm thinking trigonometry, SOHCAHTOA. All right, so I'm looking for Z, which is the adjacent. I have the hypotenuse, so I can just do some trig. So what would that be? The cosine of 25 equals Z over 4. And then from here to solve, I would just need to multiply in my calculator. And I don't have a calculator on me, but make sure that you're in degree mode. Type it all in, then you will have found your Z. And that will be your answer, and you will be finished with this kind of a problem. So this is one of the harder types. Actually, for the most part, they're not going to look that bad. For the most part, you may see something more along these lines, where maybe it looks like this. And you're either going to be told that it's a rectangle, or based on how it's labeled, you are going to get to say, oh, that's a rectangle. I have a set of opposite sides that are congruent, and I see 90-degree angles in the corner, which means all of them have to be 90. So you get to sort of make your own assumptions. And then it might just give you a couple of values and then say fill in the rest. So in other words, maybe it's like this is a 3x plus 2, and this is an 11. And this is a 20, and this is a 6y minus 5, something like that. And then maybe on the inside, it tells you that, like, this is 32, and yeah, maybe that's all it tells you. And then you're supposed to find, like, everything else out about the shape, or at least all of the angles and the x and the y. So if we wanted to do that, like I said, I always start on the sides, and I don't know why, but I would go and say, well, these are congruent. So I'm going to start by finding x. Ooh, that's an 11. And then I would subtract. So x is 3. No big deal, right? Just a little bit of algebra. If I want to find y, I'd set the top and bottom congruent to one another. And this one's not as fun because it's a fraction, but whatevs. Okay, 25 over 6. So I found these to make all this match on the outside. Now I can go to the angles, which is the fun part. So for me, I like rectangles because I remember, I'm going to scroll, so don't get motion sick. Here we go, rectangle, rectangle, rectangle. Right here. Rectangles I like because I always just, this is what's in my brain, is these colored in. This one's congruent to this one, and the left one's congruent to the right one. That's how my brain thinks. So immediately I am like, oh, cool. So if these are congruent triangles, and I also know that this is congruent to, hold on a sec, let's go back. Awesome. All 4 of the diagonal pieces, sorry if you're about to vomit, you can, I won't scroll again, I promise, but I don't know if you noticed up there, but it did say that all of these pieces are congruent, which means this is an isosceles triangle. So if that's 32, then that's 32. And I know that these two are congruent, so if that's 32, that's 32. I also know that I can find this because this is a triangle that adds up to 180, correct? So what is 180 minus 64? Because those two together make 64. Well, that's just going to be 100 and something. What is that? 164, 74, 16? I think that works. 116. Yeah, that works. Okay, so 116. So if I know that's 116, I know that's 116, which means that here's a supplementary line, guys. A straight line means that these are linear pairs. So now I know that this is 64. And how do I get these two angles? Well, you can do it 2 ways. You can either subtract 32 from 90 to get it, or we could do the same thing with the fact that this has to be 180 and these have to be equal. So whatever's easier for you, but we can fill those in. I think that's gonna work. No, 58. Okay, so I think 58 will work, won't it? 10, 90. Okay, so 58, and then you can just double check at the end. Is 58 plus 64 equal to 180? That's going to help you know if you did it right. And I don't have a calculator, so, and it's early, so I'm hoping I'm doing it right with my math, with my arithmetic. 58, and 64. 16. Yep, that works. Okay, so yay! So we found all the angles on the inside, and we found the x and y for the outside. So what do you know? So good times. All right, so that's kind of what they're going to look like. Kites and what's left? Trapezoids. We're going to do those later. But for any shape that's given, just please look at your picture of what's supposed to be congruent, start marking it up, and then you can start solving it. And we'll get back to the other two next week. Thank you.